I'm gonna be doing exercise 2.43. We are given a rocket of the mass equal to 7750 kg, and we have the acceleration of 2.30 meters per second square, and it was launched to a height of 530 meters. So I'm gonna just have like a sketch. Let's say it was launched from here to here before the engine failure. So let's call this H, from here to here, and this one, and this is the maximum height there. Let's call this another H, and after the engine failure, still it's gonna keep going up until it reaches the maximum height over there. Let's call this distance small h. So the first question is, what is the maximum height this rocket will reach above the launch pad? So the maximum height, first of all, let's find the velocity of the rocket. We need to find the velocity. From the formula, A, that's acceleration, is equal to v square minus, this is final, minus the initial velocity square divided by 2h. H is the height. So the final velocity from this equation will be given as is equals to 2ah, because it was fired from rest, meaning initial velocity was 0. So our final equation will look like this. So to find this, so v squared is going to be 2 times 2.30, which is the acceleration, multiplied by the height, the one we have over here, 530. So v is going to be the square root of 2 times 2.30 times 530, and this will give me 49.4 meters per second after you're doing everything and taking the square root. So that's the velocity of the rocket before the engine failure. And now, after the engine failure, we need to find the maximum height the rocket went to. We can use this formula, v square minus v naught square is always equal to 2ah. After the engine failure, now the force that is acting on the rocket is the force due to gravity. So our acceleration is going to be g, and because it's going upwards, so it's going to be minus g. It's going against the force of gravity. So we're going to have our equation looking like this, and we have to know that at the final, at h maximum, at maximum height, the final velocity is going to be 0. So having that in mind, we're going to have the equation looking like this, because this is going to be 0. So we're going to have minus v naught, that's the initial velocity, is equals to 2ah, because this is like 0 minus that one. So we don't have to include that, and we're going to end up having minus v naught square is equal to ah. And we said our a in this case is negative g. So if we substitute here, we're going to have v naught is equals to negative 2gh. This negative comes here. So the negative and negative will cancel. Finally, we have the v naught to be equal to v naught squared equal to 2gh. So this is gonna be now this is gonna be the initial velocity of of this rocket, the one that we found on top here. So this is going to be like 449.4 squared is equals to 2 times 9.8 times h, the one that we don't have. So h is going to be 49.4 squared divided by this times t is 19.6, of course giving the h to be 124.5 meters. So the total height, call it y, is going to be equal to h plus h, and this is 124.5 plus our initial h was 530. So this is giving us 654.5 meters. So that's the question was, what's the maximum height? So the maximum height is this one. So y is from here to here. This is y, which is this plus this, and the total is 654.5 meters. I'm gonna move to part P. Part P, the question is asking how much time after engine failure will elapse before the rocket comes crashing down on the launch pad. So what we have to do first, this part P, what we have to do first, we are required to find the time. So let's find the time taken to reach the H maximum. Time to reach H maximum, H max, like maximum height, is gonna be given by the equation V is equal to V naught plus AT. And of course our A in this time round is, our A is gonna be minus G. It's gonna be gravity, force of gravity, but because it's going up, it's gonna be again, so we change the sign. So we're gonna have T, and of course we know that our final at H maximum, our final velocity is always 0. So we're gonna have 0 is equal to V naught plus AT. This is gonna be 0 is equal to V naught minus GT. We're substituting negative G for A. So, and this is gonna be like, so if we make T subject the formula, T is going to look like to be V naught all over G, if you cancel your signs and everything. So this is gonna be 49.4 meters per second divided by 9.8 meters per second squared, and of course this is gonna be this gives me 5.04 seconds. Another thing we need to find is time taken for free fall. Time taken. The time taken the rocket to come all the way down. So because after it reaches maximum height, it's gonna come down free with a free fall. So we're gonna use the formula H is equal to V naught T plus half GT squared. And you realize now this rocket is coming down, so our G is gonna be positive G, so we're not changing the sign, so we're gonna keep the sign. So at maximum height, our initial velocity, because it had to stop then start coming down, so this is gonna, the V naught is gonna be 0 plus half GT squared, and of course this is equal to H. So our H is going to be half gt squared, and this is going to be half times 9.8 times t squared, because our t squared, our height in this case is gonna be the total height, the one we had before, which is gonna be 654.5 is equal to this one. So our t squared is going to be 654.5 divided by half times this one is the same as 4.9. Therefore, our t is going to be the square root of 654.5 divided by 4.9, giving me, let me see my calculator here. Good, this gives me 11.6 seconds. Time is in seconds. So total time total is going to be equal to 5.04 plus 11.6 seconds. These are seconds, so it's gonna be equal to 16.6 seconds. So that's the answer for part P. I'm gonna move to part C. Part C says how fast would it be moving just before it crashes. So we can use the formula here that we know, that goes as v squared, this part C, v squared is equal to 2ah, and then in this case a is going to be g, because due to force of gravity is freely falling down. So we're gonna have our answer to be, so v squared is gonna be 2 times 9.8 times 654.5. So v is going to be 2 times 9.8 times 654.5 square root, and this is giving me the answer to be 113.3 meters per second, because I think we require to give in 3 significant figures, so I'm gonna have it as 113 meters per second. And that's the end of part C. That's the final velocity before it falls down. So that's the end of that exercise. Any question and comment, they are always welcome. Thank you.